So for that again we are going to use the same equation, but values will be different. So same equation. So VC square this time, this was VB. So this time VC square minus U square equal to 2AS up to C. So VC is, we need to find VC, and U square plus 2ASC. So this much we are going to do. So U was 12 and A is -1 and S is 64. You can see S is 64. 40 plus 24. So this is 64. So you can write 64 and we will solve it. So VC will be how much if we solve? That it will be 144 minus 64 into 2, that is 128. So if you take root of it, that will be what? Plus minus. So I think it is 16 root. So plus minus 4. So again we are getting two different values, plus 4 or minus 4. So again we have same explanation. At this point the velocity will be 4 meter per second while moving forward, and while returning the velocity will be minus 4 meter per second. So this is the velocity at these 2 points. Next question we can have, what will be the maximum displacement of this particle A in the forward direction? Means the maximum point, suppose this point is called D, how much is the value of D from A? Means what is the distance of D from A? That is the next question. So next question we will write maximum displacement in forward direction. So for maximum displacement, what we can do is either we can use maxima minima, or we know that maximum displacement occurs when velocity becomes 0, and the velocity becomes 0 and then particle will return back. So this is the scenario at maximum displacement, the velocity of the particle becomes 0 and the particle will return back. So we can use the same formula, VD square minus U square equal to 2ASD. So what we are going to use is VD will be 0 this time because the particle is going to stop there, and U is 12, acceleration is -1, and SD. So how much will be SD? The SD will be minus 12 square by -2. So that is coming how much? 64 meter. So the 72 meters. That is coming how much? 72 meters. So the maximum distance the particle will come, this point will be how much? 72 meters. So this is the maximum displacement of particle in the forward direction. One more question we can add here. At what time the particle will return back to its original position A? At what time particle returns back to original position A? So for this one, what we are going to do is the displacement we have to take 0 because particle is reaching to the same point A. So we have to take displacements to be 0. Or if you take displacement to be 0, and we can use this formula, S equal to ut plus half at square. So what we will do is S equal to ut plus half at square, and we will take displacement to be 0. U was 12 t and half -1 t square. So if you solve it, you will get two different values of t. One is 0 and other will be 24 seconds. So the particle will be reaching at point A at t equal to 0 and t equal to 24 seconds. So 0 indicates the initial point. 0 indicates the initial time when initially it was at A. And after 24 seconds, it will again return back to A. So that's why we are getting two different times. This is for the initial time, the initial point, initial, and this is the after 24 second, the answer which we needed. So this will be the answer after 24 seconds. Okay, one more question we will add in it. What is the displacement and distance up to 16 seconds? Find distance and displacement up to t equal to 16 seconds. Okay, so the formula we have, so S is ut plus half at square. So u is 12, t is 16 plus half minus 1 and t is 16. So if we solve it, how much we are going to get? 160 and okay, so let it be like this only. It will be easier to solve. So 16 square means it is 16 into 8. We can write it like this, 16 into 8. So if we solve it further, it will be what? It will be 16 to 4. So 64 meters we are getting. So up to 16 seconds, the displacement is coming 64 meters. The formula is for displacement. So we are getting displacement up to 64, up to 16 seconds is 64 meters. So what will be distance now? So what is the basic difference between displacement and distance? If particle is moving in a straight line, then we need to see only one thing for separating distance and displacement. That is, if particle is going forward and then returning back, see, from A to D, it has covered a displacement of 72 or distance of 72. And then after this time, if it returns back to suppose this point, we are getting 64. We are getting the displacement is 64. So displacement is 64 means what? It is at which point? It is at point C. That is 64 displacement. So 40 plus 24. So this corresponds to what? This corresponds to point C actually. This corresponds to point C. So displacement is 64. But if you say distance, for distance what will happen? The particle is going forward and then returning back. So for distance we need to add the whole path length. So it will be what? 72 up to D and then this distance. So what we are going to do for distance is 72, which it has already covered. Then we will do 72 minus 64 mod. This will be added. I am repeating it again. Since the particle is returning on its path from D to C, and how do we know that it is returning back? Because we know that at this point the particle was initially at 8 seconds. So if we had been asked that find distance traveled up to 8 seconds, then we could write directly 64 will be the displacement and 64 will be the distance as well. But it is asked for 16 seconds. So what is happening actually is after 8 seconds the particle is going forward and it is going at maximum distance and then it is returning. So at 16 seconds it is again at point C. So what we are going to do is we will take the 72 meter up to distance up to point D, and then after that what we will do is we will take the difference 72 minus 64 mod. This will be added to 72. So that will be the distance traveled. So the distance traveled we can write as the distance traveled will be the 72 up to point D and then 72 minus 64 mod. So it will be how much? This is 8. So 80. We are getting 80 meter. So why we are doing like this? Because the particle is returning on its path. If it does not return in its path, if it does not change its direction of velocity, then we could take the displacement and distance to be same.